Hi, my name is Kosei Matsutani and Hikaru Ando and Ken Yoshida. Thank you for selecting us at the first prize. Our team name is AquaMind. We will change the world with blue carbon credits. So here's a question. Have you ever heard of blue carbon? Some of you already know this word, but what is blue carbon? Before explaining what the blue carbon is, please take a look at this picture. This picture shows the amount of CO2 emitted from human activity and absorbed by ocean runs. And as you can see this picture, the ocean has greater capacity to absorb CO2 than the run does. So what is blue carbon? The blue carbon is a carbon stored in coastal and marine ecosystems, and coastal ecosystems contain plenty of plants such as mangroves, seagrasses, and seaweeds. And blue carbon ecosystems absorb GHG roughly 30 times faster than rainforests. And about 83% of the global carbon cycle flows through the ocean. And according to the journal Nature, the wealth generated by blue carbon ecosystem is estimated to exceed $190 billion annually. For example, kombu, which is typical seaweed found in Japanese ocean, absorbs CO2 5 times faster than the Japanese sea dove. Focusing on Japan's geographic aspects, Japan has the 6th largest exclusive economic zone in the world, which is about 4.47 million square kilometers. And we could safely say that Japan is one of the richest blue carbon countries in the world. To introduce blue carbon into our economic systems, here's one important word, blue carbon credits. We can issue credits to fishery association and local governments that protect the seagrass. To achieve this, we need to evaluate the amount of blue carbon accurately and inexpensively. One research conducted by Global Market Insights, the blue carbon market is expanding year by year, and it is estimated that it expands to $100 billion in 2023, and it will expand to $340 billion in 2032. We conducted an interview with a company called Mirai Sozobu Kabushiki Kaisha, which is a company focusing on blue carbon, and we explained our services to those working on it. And we asked how we could improve them. According to them, current blue carbon credit evaluation method is reliable but costs a lot. So we need to establish a simpler, faster, and less expensive survey method. Here, we define an issue to measure blue carbon credits more accurately and easily. And we propose a solution to calculate credits from satellite images and benthic classes data. So this is what we did. We utilized cutting AI models to estimate the distribution of seagrasses and making the results accessible through a friendly UI for user reference. So this is our demo. We can visualize the predicted distribution on a website using Google Maps API and can view each area using colors. And we also, and by adjusting the slider for probability thresholds, they can visualize the probability of seagrass distribution in each area using colors. This implementation was inspired by a discussion with Mirai Sozobu Kabushiki Kaisha, who emphasized the value of knowing the probability of seagrass presence. Additionally, users can move a white rectangle to any desired location and size it, allowing them to narrow down the area of interest for observing distribution pattern. So if you use our service in just one small Miyako Island, the total cost of blue carbon research will be reduced from 6.2 billion yen to almost 0 yen. Our business model is quite simple. Our service targets to G, targets to 2G, 2B, and 2C. And for the government or the Ministry of Environment, we sell the data. This data we sell will be used to show how Japan has contributed to global climate change at the global conference. And for to environmentally friendly company and blue carbon credit issuing company, we ensure the amount of blue carbon and the money paid exchange for the insurance of the existing blue carbon is paid to local fish association, and they cooperate with our field research, and those field researches provide us with a variety of data which will improve the accuracy of our AI models. This is our model case. When the company wants to show their environmental contribution by issuing blue carbon credits, while the Fisher Association is protecting the marine ecosystems, but wants the evidence of this, we provide them with on-site marine vegetation survey, and the company pays a partial fee for our services, and they get a blue carbon credits, and they can contribute to solving environmental problems. And the Fisher Association can work more protect the marine ecosystem, and which will contribute to their steady income for their livelihoods. For a data set, we used basic classification from RN Core Atlas and satellite images from Google Earth Engine as input features, and we used seagrass distribution by Ocean Data Viewer as output labels. This is a summary of our AI models. We generated features using some operations like multiplication and exponentiation, and generated categorical features using some methods like binarization or unsupervised learning, and extracted features from satellite image data using fog features and shift features and other color features. And we put those inputs into several models, XGBoost, RightGBM, CatBoost. Those are gradient based decision tree models, and random forest and TabFFN. And we optimize those models hyperparameters using Optuna. And in some models, we use some techniques called pseudo labeling, and we made 30 models in total and ensemble them and deploy those outputs by using Google Earth Engine. Our source code and services are available online. Thank you very much.